Okay, so we were seeing about periodic and aperiodic signals, and in the last class we have seen the definitions for periodicity and periodicity. That is, for a analog or continuous time signal, it was x of t should be equal to x of t plus capital T for all values of t, where capital T was a fundamental period, and for discrete time signals, it was x of n should be equal to x of n plus capital N, where n was a fundamental period, and that is the pattern. The pattern of x of n should repeat after capital N number of samples, and that was it. So this was the basic definition. And for continuous time signals, we have seen some examples, and we have seen a particular example of a composite signal. That is, if we have two signals, x1 of t and x2 of t, and if x1 of t is periodic with the time period t1 and x2 of t is periodic with the time period t2, then there was a question whether when we add those two signals, when we add, it becomes a new signal, that is a composite signal, whether that signal is periodic or not. That signal is periodic only if when you take the ratio t1 by t2, that should be equal to a rational number. That should be equal to a rational number. Rational number in the sense numerator as well as denominator should be an integer. So if that is a rational number, then the composite signal also is periodic. And how to find the period of the composite signal? Take the LCM of T1 and T2, you'll get the fundamental period of the composite signal. Okay. Likewise, we'll just move on to the discrete time signal. Okay. So I just want to prove one thing, that is x of n. Suppose you have x of n as this signal, that is e raised to j omega naught n. And we know by definition, this is the definition, x of n plus capital N should be equal to x of n if this is periodic. Okay. That means instead of n, I substitute n plus n here, and that should be equal to x of n. Okay, that is by definition, if I substitute, this should be equal if that is periodic. Okay, I'm opening the bracket, I'll get this one, that is e raised to j omega naught n, e raised to j omega naught small n should be equal to this one. Okay, how can this be equated? Okay, if they are periodic, this equation should hold good. How they are periodic? If they are periodic only when this whole term is 1, that is e raised to j omega naught capital N is equal to 1. Now how this term is 1? When the angle, that is j theta, when theta is a multiple of 2 pi. When theta is a multiple of 2 pi, then definitely e raised to this complete term will be equal to 1. That means omega naught n should be equal to 2 pi k. That is omega naught by 2 pi is equal to k by capital N. That is, again you see that discrete time signal is periodic only if omega naught by 2 pi, that is the angular frequency by 2 pi equal to a rational number. Okay, so one thing is sure, pi is never a rational number. Pi is never a rational number. So if this pi does not, when you substitute a value for omega naught, you substitute a value for omega naught, when you substitute the value for omega naught, if this omega naught is not a multiple of pi, keep this in mind, if omega naught, when you substitute, is not a multiple of pi, then that pi and pi does not get cancelled. That means this pi remains. That means this denominator is never a rational number. So if omega naught is not a multiple of pi, then the corresponding discrete time signal is aperiodic. Suppose if we have omega naught as a multiple of pi, for example, you have 3 pi here. When you get omega naught as 3 pi, then pi and pi gets cancelled, you get 3 by 2. 3 by 2 equal to k by n, that is 3 by 2 is a rational number. Then the discrete time signal is a periodic signal. Okay, so important conclusion is that if omega naught is a multiple of pi, then that's a periodic signal. If omega naught is not a multiple of pi, then that is an aperiodic signal. We'll just see some examples. That is, here are a few examples. See, I told that this is omega naught, that is 0.02 pi. So this is a multiple of pi. So definitely this is periodic. Here also this is periodic. But here see this example, cos 4n. Here omega naught is 4. 4 is not, it's not a multiple of pi. So it is aperiodic. Okay. Now we'll see example number of D. That is this one we'll see. That's a composite signal. Individually they are periodic because omega naught is actually 2 pi by 3. Here also omega naught is 2 pi by 3. Individually they are periodic, and this is the first period, that is 2 pi, that is for the first signal sine 2 pi f1 n plus cos 2 pi f2 n, and you can say that the the fundamental frequency 2 pi f1 is equal to 2 pi by 3, or f1 is equal to 1 by 3, that is equal to k1 by n1. Likewise, you can say f2 also is equal to 1 by 5. Okay, so what is the frequency is this one, what is the time period, just the reverse of that, that is 3, and here it is 5. Okay, now what is the fundamental period of that composite LCM of n1 and n2, that is n1 by n2 is equal to 3 by 5, that is 3n2 equal to 5n1. Okay, so that is the case. So that is a fundamental frequency. Okay, and okay, so n1 is already given, so n1 is 3 and n2 is 5. So what is the fundamental frequency of the composite signal, that is 5 into n1 or 3 into n2. So 5 into n1, what is n1, that is 53. So 3 into 5 is 15, or that should be equal to 3 into n2. What is n2, that is 5, that is 3 into 5 is 15. So the fundamental frequency of the composite signal is nothing but 15. Okay, likewise you can see this one also, you can just, there are numerous examples that you can just solve that. Okay, now we'll go to the next classification, that is the energy and power signals. Okay, of course you many a times you calculate power of a signal and energy. Okay, so power, instantaneous power, you know, that is for an electrical circuit is nothing but V of t into I of t, or V square of t divided by R, or if in terms of current it is I square of t into R. Okay, suppose if you want to get a normalized power, what is normalized power? Just put the value of R is equal to 1. If you put R is equal to 1, normalized power P of t is nothing but V square of t or I square of t, or nothing but instantaneous power is nothing but you square the sequence, you find the absolute square of the signal, then you get the instantaneous power. Okay, now what about the average power? Okay, so we'll see the average power. So average power is nothing but, average power means this one, that is absolute square of that sequence integrated from minus infinity to plus infinity. So here you're putting a substitution for infinity, that is t to t, that is minus t to t, where t tends to infinity. So what is the base? There is one t towards minus infinity, there is another t towards plus infinity. So what's the total base? That is 1 by 2t. So average means the sum is this one, sum is provided by the integration divided by the base is nothing but 2t, where t tends to infinity, and integration will have dt also, and that is in watts. Okay, so if you have the average power, then you can get the value for what? Energy. How will you get the value for energy? Energy is nothing but, that's very simple. Energy is nothing but you multiply it with time, that is what, 1 by 2t gets cancelled, you come power multiplied by time is nothing but energy. So 2t gets cancelled, the remaining thing, that is the limit t tends to infinity, integration from minus t to t, mod of x of t the whole square dt is nothing but the energy, that is in joules. Okay, now what is in discrete time? Discrete time is nothing but this one, that is square energy. Just like that, instead of integration you have summation, that is n is equal to minus infinity to infinity mod of x of n the whole square. Okay, likewise discrete power is nothing but integration, instead of integration you have summation square of this absolute square, then base is 1 by base is there it was 2t, here you have 2n plus 1. Why it is 2n plus 1? Because this actually n actually denotes the number of samples. Okay, that is you're moving towards minus infinity, that is total number, n number of samples, capital N number of samples. When you move from 0, when you move from 1 to positive n, you have another n number of samples. Likewise, when you move from minus 1 to minus n, you have another n number of samples. So when you move from 1 to n, you have n number of samples. When you move from minus 1 to minus n, you have another n number of samples. Okay, in between you have a sample that is at n is equal to 0, and that is how you have a 1 here. So 2n plus 1 is the base. Okay, where n tends to infinity. And what is the definition? That is, when you calculate the power using any of those equations, that is if it is analog you have to apply the integration, if it is discrete you have to apply the summation, then the resultant should be having a value which is less than infinity. And for an energy signal, energy is having a value but power is equal to 0. Okay, and all non-periodic signals are examples of energy signals. Likewise, if it is a power signal, when you do the apply the equation, you should get a result which is less than infinity, and for that energy is infinity. Okay, so a power signal is having when you a value of power less than infinity, but energy is nothing but infinity. So periodic signals are examples of power signals. Okay, there can be signals which are neither energy nor power. Okay, so we'll first see a very important thing, that is, this is very important, that is, determine the power and RMS value of signal x of t is equal to a sine omega naught t plus theta. So this is your signal, it's a continuous time signal. When you apply the definition for power, that is limit t tends to infinity 1 by 2t integration from minus t to t mod of x of t the whole square dt. You substitute of instead of x of t this value. Okay, and you know what is sine square theta. What is sine square theta? It is 1 minus cos 2 theta by 2. You apply that one, then open the integration. This is the first component and this is the second term, and when you see that you are performing the integration over a complete cosine waveform. When you perform the complete integration over a complete cycle for a cosine or sine waveform, this term becomes 0. So this is 0. Okay, this is 1. Okay, so integration of dt is small t, and when you apply the limits, what happens? When you apply the limits, it is t minus of minus t, that is t plus t, and this is 2t, t and t gets cancelled, remaining is a square by 2. So this is average power. Average power is nothing but a square by 2. So what is RMS value from average power? RMS value is nothing but root of average power, that is root of a square by 2, that is equal to a by root 2. This is a very important result. Okay, now for this one, what is energy? I told that if it is having a power which is less than infinity, a by root 2 is less than infinity. This is a number, this is a value. So what about the energy? Energy should be equal to infinity. So energy is nothing but, if you apply the same equation and substitute everything, this component gets 0. This is integration, this is capital T. When you substitute limits, that is infinity minus of minus infinity, the whole thing becomes infinity. So energy is infinity. Okay, now there are very important some workout examples here. You can just go through that. See, determine power and RMS value of the following signals. You have x of t is equal to 7 cos 20t plus pi by 2. Simply write from this one, that is a square by 2 is the average power, and a by root 2 is the RMS value. So what is the average power? A square by 2. So what is a square by 2? That is 7 square by 2. 7 square by 2, that is 24 by 24.5 watts. What is the RMS value? It is nothing but root of 24.5. Okay, likewise you have the next thing, that is 12 cos. This is the two component, two signals. When this two signals are added, you have x of t. So what is the average for? Here you have a square by 2 plus another a square by 2, that is a is 12 here, a is 16 here. So 12 square by 2 plus 16 square by 2, that is equal to 200 watts. So what is the RMS value of this combined signal? That is root of 200. Okay, that is the RMS value. Likewise, you can solve this problem, that is this one also. This one you apply the basic trigonometric formula, you get this one, and then you can find it as average power, it has 16 watts, and the root of 16 is the RMS value, that is 4. Okay, now we will move on to some other signals, that is if you have such a signal like x of n is equal to 1 by 2 the whole raised to n u of n. Okay, so by definition energy is nothing but limit n tends to infinity, n going from minus n to plus n, square sum of that is square of the absolute square of x of n. Okay, you substitute instead of x of n as 1 by 2 raised to n. Okay, now if you take 2 inside, this becomes 1 by 4 raised to n. And if you substitute for u of n, you know what is u of n. U of n starts at n is equal to 0 and goes up to plus infinity. So it's a perfectly right-sided sequence. When you do that, the summation, which is actually from minus n to plus n, becomes from 0 to capital N, where n tends to infinity. So if you substitute that infinity also, this becomes a thing 1. Okay, this is the resultant. Okay, okay, that is equal to, this is a geometric progression. That is, this is I'll take this one in the next class. Thank you.